Hello, we are from Industrial Physics program, and the topic we choose is why the sky is blue and sunsets are red. And this is our member. Our first member is Vyonitha Jikim. Second, Sharnita binti Jalubi. Third, Khairiana binti Nurdin. Fourth, Nurnajah Amira binti Rosbek. And the last one is Linda Janilon.
Hi, my name is Sharnita binti Jalubi with metric number BS23110199. Have you ever looked up at the sky and wonder why it's blue during the day, but turn red or orange at sunset? This colorful change is something we see almost every day, but not everyone knows why it's happened. Sunlight may look white to us, but it's actually made up of many colors, each with different wavelength. As sunlight enters the atmosphere, it collides with tiny particles of air and dust. This process is called scattering and affects different colors of light in different ways. In this video, we will explore more about how this scattering works, besides understand behind the sky's changing colors.
Hello, my name is Khairiana binti Nurdin and my metric number is BS23110291. And today I would like to share two things. The first one is research background and the second one is research objective of the science behind why the sky appears blue during the day and why it turns red or orange during sunset. Let's start with a phenomenon called Rayleigh scattering. When sunlight enters Earth's atmosphere, it encounters tiny particles which are mostly air molecules. These particles are much smaller than the wavelength of visible light and they scatter the light in all directions. As we all know that light is made up of different colors, each with a different wavelength. Blue light has a shorter wavelength and is scattered much more than red light, which has a longer wavelength. So, during the day, when the sun is high in the sky, the blue light gets scattered in all directions, making the sky appear blue. But things change during sunrise and sunset. At those times, the sun is near the horizon and its light has to pass through a much longer path in the atmosphere to reach us. As it travels this longer path, even more scattering occurs. Most of the shorter wavelength light, like blue and green, is scattered out before it reaches our eyes. What remains are the longer wavelength, which are reds and oranges. That's why we see those beautiful warm colors in the sky during these times. The next thing I want to share is our research objectives. We have 4 objectives. The first one is to understand why the sky appears blue during the day. The second objective is to explain why the sky turns red or orange during sunrise and sunset. The third one is to show how sunlight and the atmosphere work together to create different sky colors. And the last one is to explore how Rayleigh scattering affects the color of the sky. All of these objectives will be explained more in depth in result and discussion part. So, the next time you admire a colorful sunset or a bright blue sky, just remember it's all thanks to Rayleigh scattering and the journey sunlight takes through our atmosphere.
My name is Vyonitha and I will present our literature review. These phenomena are now well understood through the physics of light scattering, primarily Rayleigh scattering. The process has been named in honor of Lord Rayleigh, who in 1871 published a paper describing this phenomenon. The blue color of the sky and the red hues of sunsets are primarily due to Rayleigh scattering, influenced by the angle of the sun and the composition of the atmosphere. Shorter wavelengths Blue and violet are scattered more efficiently than longer wavelength red and orange. The angle through which sunlight in the atmosphere is scattered by molecules of constituent gases varies inversely as the fourth power of the wavelength. Hence, blue light, which is at the short wavelength end of the visible spectrum, will be scattered much more strongly than the long wavelength red light.
Hi, my name is Nurnajah and I'm going to present about the methodology. This research uses a qualitative and theoretical approach to investigate why the sky appears blue during the day and red during sunsets. The study is based on literature review and conceptual analysis of scientific explanation related to the light scattering and atmospheric physics. The main method of this study is literature review, which is a review of existing scientific literature. We took information from educational websites and scientific literature to understand the theories behind the colors of the sky and sunsets. This includes the work of physicists and atmospheric scientists that explain Rayleigh scattering, the behavior of light in the atmosphere, and the impact of the sun's position on sky color. Next is conceptual analysis. Concepts such as Rayleigh scattering, light wavelength, and angle of sunlight were analyzed to explain how they contribute to the sky's color at different times of day. Ideas from various sources construct a clear explanation without the use of direct experimentation or data collection. The last one is secondary source evaluation. Secondary sources were used including educational materials from physics department. These sources provide reliable explanation and models of how sunlight interacts with atmospheric molecules.
In the first objective, we need to understand why the sky appears blue during the day. The sky looks blue because of Rayleigh scattering. We all know that. Where shorter wavelengths like blue are scattered more by air molecule. Even though violet is scattered more, we see blue because our eyes are more sensitive to it, and the atmosphere absorbs much of the violet light. As a result, we perceive the sky as blue during daylight hours. In the second objective, we need to explain why the sky turns red or orange during sunrise and sunset. During sunrise and sunset, the position of the sky is lower on the horizon. The sunlight requires a somewhat longer path through the atmosphere to reach our sight. Most of the shorter wavelength like blue, violet is scattered out of the line of sight in this action path. Thus, only the long wavelength light, example red, yellow, orange, reach our eyes.
Hey, hi! Now I'm gonna explain the results and discussion based on our topic. The changing colors of the sky, it actually depends on how light behave towards the wavelength and the atmospheric condition. Atmospheric condition that we can take as an example is pollution, dust, and water vapor. All of this can enhance the scattering effect, which causes the sunsets look more vibrant or the sky looks hazier on certain days. And based on Rayleigh scattering theory, the color of the sky it depends on the light wavelength and the sun's position. So what are the conclusions that we can get from this research? Okay, the conclusion that we get are the color of the sky it changes because of the Rayleigh scattering effect, right? Why? Because the sunlight it hits tiny particle in the air. Why do we see blue during the day? Because
When the sun hits the tiny particles, blue light it scatters more than other colors. So that's why we see blue during the day. Why do we see red and orange during sunset? Because as the sunlight travels, it hits more and more particles, and as the time goes on, the blue light is scattered away, so all we left is vibrant colors. So that's why we see red and orange instead during sunset. I think that's all the conclusion that we can get.